Hi guys. Guys, am I audible? Okay, that's great. So let's get to our things. I'll just check with the other people as well. Audible. So if not, try reconnecting once if anybody is there. Okay, it should be connecting, right? Okay. Okay, let's get started. In the previous session, like we discussing the DNS service provided by Amazon, which we call it as the Route 53 or Route 53. So whichever you can call it, right? So we have discussed about like what is DNS and what is Route 53 and how it works, right? And then we have created some examples for the DNS records, like a record, CNAME record kind of. We understood basic things, and then we went into the deeper topic, which is called the routing policies. So where we have seen like we have around like 5 to 6 policies. We have discussed about simple policy, which is basically nothing but the traditional DNS, right? So whatever the IP address is mapping to a name, when somebody browses that name, it will be automatically redirected. I mean, the request will go to that particular IP address. When somebody browses the name, so it will be having an IP address in the DNS, so that request will go to that particular IP address. And wherein we have like other routing policies which can make things happen based on the mechanism we have used or the based on the routing policy. Like if you take weighted routing policy, we have seen that, so we can give some weight to the servers, right? So if you have a server which can have which is like kind of a good configuration, right, high end specifications, then you can tell Route 53 to route the more requests to that particular server instead of routing evenly across all your servers like a load balancer. So instead of a load balancer, we can go with the weighted routing policy, where it can, based on the weight, it will route the traffic, right? The higher weighted server will get more request, the lower rated server will get lower request. It's like that. And then we have discussed about the latency routing policy, right? So based on the user, the customer, from wherever he's trying to browse that particular website or application, right? So from that location, from that user location, so whichever is the nearest server, he will be routed to that nearest available servers, right? So which is like low latency. So which a user request can reach with lesser time possible. So whichever the server can reach lesser time, right, then that will be the server for him to get the application, to get the website. I mean, from that server, he will get the application or the website. So till that, I think we discussed about it. So we didn't discuss about these two uh, policies more. And if we complete this, we can conclude the Route 53 as well, which is called the failover routing policy, right? And which is very simple actually. The failover routing policies, I mean, we have already discussed this regarding the failover. So if you um, take considering the RDS multi availability zone option. So what is basically the multi AZ of the RDS? So when we select multi AZ for any database instance, what AWS will do? AWS will create two database instances, right? So it will create one database in one availability zone and one more database is in another availability zone. So it will be like AZ1 and AZ2. Let's take an example, and this will be primary and this will be secondary. So once database is created, we'll be having an endpoint right? So that endpoint will be normally mapped to what? The primary database instance, whatever might be, right? So if AZ1 is a primary database instance, it will be mapped to like this. Now if there is any issue from the AZ side or from ODS service side, I mean there is some issue, right? It might be a physical issue or a network issue, or might be there might be some natural disaster, whatever happens. If the primary database is down, the primary AZ down, what will happen? AWS automatically, quickly, immediately, within no time, it maps this endpoint to the secondary server. So basically, it will make this as primary, something like that. Now the endpoint will map here. So this in our basically in the technical terms we call it as failover. Means when something failed, it will over to another. Right? Right. It's a concept we call it as failover. Right. So using the same concept, Route 53 also has an option called failover. So simple, just like you, yes, exactly, Khalid, true. So, right. So simply remove these two databases with the two instances. Let's say you have one instance. Take an example, and the one more instance here. Take this as consider this as primary and this as secondary, and we can map some name, some www.some.com, the name, and then what you can do, you can map that to. So here you need to map to both actually. I mean, you need to create two records, and while creating these records, what we'll do is we'll specify like which is primary and which is secondary. So which is primary and which is secondary. So how it will work is that whenever a user browses this website, so he will always go to the I mean the request will always go to the primary server, whichever be the primary server. Let's say in our case we are talking, I mean we have considered this as the primary server. So all the requests will go to the primary server, right? And if there is an issue with this primary server, if this is down, then automatically what will happen? The request will went back to the secondary. So automatically the request will go to the failover. So it's like that. So this is what basically the failover routing policy is all about. Let's try to create that. It's very simple. It's very simple thing. So let's go and implement. So to implement that, what we'll do, we will take you know one let's take one server is our primary instance, and the other server is like the failover instance. Let's open our regions where we have the servers running. So we have created some servers with elastic IPs, right? So we have created the health checks as well for this process. Okay, this Mumbai one and this North Virginia one and this is a London one. Okay, so basically we have all these things. We have Mumbai server. Let's take an example. Mumbai server. I'll just check is it working or not. It should work, right? Yeah, it's. Oh my God, it's not working properly. Might be some issue with the database. Seems to be. Okay, maybe let's check with this one. Okay, this is working fine. And what we have in Singapore actually, just check and see what was this. It's a basic Windows server. Okay, it's fine. Oh, it's something is anyway. Something is coming. Let's go with that. If something or the other is displaying. Okay, let's take an example with this one only, right? So this Mumbai one is, let's say, our primary. Let's go to the Route 53 and create this record as failover routing policy. go to the hosted zones and select any domain, whichever is fine. So I'm going with again graalabs.com here. So I'll create the record. Let's take an example of let's say app.groundlabs.com, and I'll map. I'll copy the IP address of Mumbai. This is the IP address of Mumbai server. I'll paste it here, and in the routing policy, we'll select the failover. Just click on failover, and when we select failover, if you come down a bit, you can see there are some options. This set ID is nothing but just a tag. Okay, nothing else. And the other two options which we need to uh, select or specify is this one, failover record type, and as well as associate with the health check, right? So this failover record type, what we are doing is basically we need to select this server is what, it's a primary server or secondary server. We just need to mention, let's say I want to go with the primary. This is so, which means whenever somebody browse app.groundlabs.com, all the requests will come to this server, right? So whatever the content in that server, it will be displayed. And what we discussed in the failover, if that is down, right? So if this is down, it should go back to the secondary. But how route 53 will identify or evaluate if the server is down? Then we'll take the help from the health checks, and we'll associate the health check which we have created for the Mumbai one. Let's click on that because it's a Mumbai server, right? So we have associated a Mumbai server's health check. So it will evaluate this health check. As long as the health check is healthy, route 53 will transfer or the route the request to this server. If this is unhealthy, then it will send the request to the secondary server, whichever be the secondary server it is. So we have not yet created. Let's click on create here, right? Simple thing. We have created, and then click on create record set, the same name, and this time what we'll do, we'll take, let's say North Virginia or whatever it is. Like, let's say London. Copy London is our secondary server. Copy it. Select failover, and this time I'm selecting secondary, right? And here what I'll do, you want to associate with health check? I mean, if you want, you can associate with health check, but there is no point in associating a health check with the secondary server because primary is down, secondary is there. If secondary is down, there is nothing there, right? So it's like that. So I mean, you can associate, but there is not much meaning to it, wherein it will be meaningful when you have like couple of more secondary servers. So you can make some more secondary server, let's say. So based on that, you can do it. But let's click on create. I don't want to associate with any health check. Let's click on create. Now you can see that app.groundlabs.com, which is pointing to the two servers, but which is our primary. The primary is basically the Mumbai server. So now whenever I browse app.groundlabs.com, I'll be pointing to the, now you can see this ICAM Private Limited, the WordPress site. I think due to that RDS, I think it's not working properly. So let's try accessing from different locations even using that proxy site so that we can understand the how it's properly working. Let's open that, copy the URL, enter. So I'm trying to access from different location. You can see that it's Europe 0. Oh, sorry. What is like this? Let's click on it. Oh, what happened? Oh, there is some issue seems to be. Fellow routing policy secondary. Yes, fellow routing policy primary. It's think it's proper only. What is kind of like, no, it's sometimes what's happening. Oh, seems to be. Wait a second. Let's try from a different machine maybe. this one. The key. So it might be an issue with the security groups. Yes, I'll just check select anywhere so that I'll not have any issues with it. Click on connect. Yep, it's asking for the username password. Yes, to connect. I don't know why it's happening like this. It should not. Okay, let's open Internet Explorer and try accessing the website. So this server is in Singapore. Oh my God, what's happening? Why this is kind of made a mistake or okay, so the issues here. Okay, I think somebody's deleted my health checks. That's where the problem is. You see that? It's Mumbai, something is different. Somebody has deleted. So that's where basically it's like not able to respond properly. Okay, let's go with this. So we have to change the policies as well. That routing records which we have created, we need to map with the new. Guys, when you have completed with your, with your things, you delete these health checks as well. I don't know, like somebody has created, it says that it has been unhealthy. You can see that. You can go and delete it because it's of no use, right? You might have already, somebody, whoever it is, have already deleted these servers. And, okay, if we go and see, let's I will delete these things so that I will not have, maybe I cannot be able to Okay, now I can see this London and Mumbai Satish, which are basically comes as healthy. So I'll go here, sorry, in here only, right? So I'll go to that records. So this is the one, it's a primary which we map to a wrong Mumbai one. So we need to select the actual Mumbai one, save record. And the same way, anyway, we have not selected this one, right? So it's fine. So now we need to, okay, let's wait. It will take some time because we just modified, right? Okay, now till the time we'll go with uh, the one more policy, which is called geolocation routing policy. So I'll brief it what it is. Then we'll go back to the failure routing policy till the time it will complete that configuration and will be updated across the DNS. Okay, so this geolocation routing policy is kind of a way similar to latency, but it's not latency. So what is this geolocation routing policy? If we can see that it has the name itself. By seeing the name, we can understand it's a geolocation, which means this routing policy is based on the geolocation, right? So what we can do is, while creating the records, same like for failure we have selected one is primary, one is secondary, right? So the same way, when you select geolocation routing policy, in that options what we can do is we can select the specific location by either continent or the country, which means, let's say if you want some continent users should go to a particular server. Let's say I want all the Europe users should go to my London server or maybe some Singapore server. Then you can specify that. You select the geolocation routing policy, and in the options we have to select that continent as Europe. Or let's say if you want to select, let's say some country, Brazil. So you want all of the users whoever is accessing from the Brazil country, right? Or maybe from China country, based on country, and you want to route all those users basically to some server. So this is how basically this geolocation routing policy will work. So we are like specifying the exact location. We are specifying the exact location, right? So how we can create is, let's try to create this as well, the geolocation routing policy, by creating a record and say that, let's say media dot something, we create a name, and we'll say that, let's say all of India users should go to, take an example of Mumbai instance. So whoever is accessing my website, webmedia.gravelabs.com, should get the content from Mumbai server, right? So forget about the health checks and all those things now, right? So we can integrate with health check, but let's forget about that for now. Let's, when we select the geolocation, now you can see that you can choose a location here. You can choose a locations either by continents, right? Or if you go down a bit, you can start to see the countries. Now you can see that countries have started: Andorra, United Arab Emirates, Afghanistan. You can see, like, so it will goes on, all the countries list will be there, right? Now what I want like all India users, like just select India. And then if you want to associate with health check, you can do that, but I don't want for this. Let's leave some tag, so say Mumbai server, something like that. Let's click on create. And let's go there here and take an example. Okay, let's London. Copy this IP address, and this time, now what we did, we have created for country, right? Let's create the for continent, let's say. So all of Europe users, Europe continent user should go to geolocation, should go to, let's have select the continent here, Europe, and give some name, some EU continent, something like that. Okay, and just click on create here. That's fine. Now I have created, right? And let's go with the same thing, create record set, media. And this time I'll copy the North Virginia IP address, this one. I'll copy it to, let's say, uh, okay, let's copy it to North, okay, the North America continent. Let's go ahead and see where is the North America continent. Yes, that's North America. So this basically means like United States users will go to the North Virginia, right? So let's click on create. So these are basically we can do the geolocation mappings here. So what I did, I just did the geolocation mappings. So I'll just do the same, I mean picturize here so that you can understand what I just did. So maybe here it will be good. So now I said we have 3 servers, right? A Mumbai server, London server, and as well as North Virginia server, right? Yes, we can do it by country and continent, whichever it's fine. Now I'll map some name, which is the name I mapped media.gravenlabs.com. This is the name I mapped to these things. But what is the uh, condition here? Right, the condition is basically what I select is that if anybody is basically coming from India, I say map it to Mumbai server. If anybody is coming from Europe continent, whichever the country in the Europe, and North America continent. So this is how I created media.gravenlabs.com. So anybody browses in from India, they will go to Mumbai. From Europe, they will go to London. From North America continent, they will go here, right? So there is one more option here is for United States. Let's say if we go and select geolocation routing policy, if you select United States as a country, let's say if you select US as a country, so sorry, United States, let's say if we select US, United States, what will happen? There is a sublocation option is also there, but the sublocation option only for US, but there is no other country. Like if you select, we have selected India, but there is no sublocation option. So the sublocation option is basically means you can, I mean, this is an optional, this is an optional option. So you can select it or not. This is basically means even like United States is all about basically the states, right? So there will be a couple of states in that. So now you can route the request if you want based on the states also. I mean, if you can see that you want like all of Alaska user should go to some North Virginia server, Alabama user should go to Oregon server, or Indiana state user should go to maybe some London server, something like that also you can do it. But this is only available for the United States. When you select United States as a country, when you select North America or South America, there is no option, right? So when you select United States as a country as your one, then you have a sublocation. You can see that all the different states will be there. So you're using that. You can, let's say if you select Florida, you give some name and associate to some value. Here you specify the IP address. So if anybody from Florida, right, access this website, they will go to this particular server. It's like that. So that's only for United States, not the other countries where we don't have the option. So let's go back to our failover thing, app.gravenlabs.com. Now you can see that it's came back to our Mumbai server. This is the primary one, right? And let's copy now. Let's copy and use the proxy site. Proxysite.com. Now it should work properly. Okay, enter it. Now you can see it's opening that same icon, private limited something. And if I change the location also, still it will go to the primary instance only, right? From wherever the location it is. So it's a failover, right? Failover means what? As long as your primary instance is running, what will happen? All the requests will go to the primary. but if the primary is down, then it should go to secondary instance, right? So let's do it by making that change. Let's go there and shut down the instance, the primary instance, which is in our case Mumbai, right? So it should go to secondary. Let's verify that. So it will take some time, right? And there is one more routing policy. I mean, where you want to see, Ashok? I mean, where you want to see the traffic here? If you want to see the traffic kind of things, I mean, the packets and all, you need to use a tool like Wireshark, where you can analyze the traffic packets. I mean, using the packets, you can analyze. Like if you are more on maybe like how many packets are going to which packets are going and all. You can use a tool called Wireshark. Okay, now I have stopped the primary instance, right? So till now it went to this ICOM private limited. Basically means this is a WordPress thing. So this WordPress we have installed on Mumbai server, right? So we know that this is in Mumbai, right? And now let's wait for some time because we just stopped the Mumbai server, right? So it should fail the health check, and then it will route back request to the another instance, which is in our case the secondary. Yes. Now let's try by refreshing it. It'll take some time because we just stopped it. And always in India, like DNS will be sometime, I mean, most of the time slow. Maybe in other states it might be fast. By here, let's go ahead here. Let's click on go. Is that health check is unhealthy? Yep. This is, you can see that it's unhealthy, right? One second. Can we trace its route by using the trace RT command? Yes, you can do it, but most of the ISPs, they will not allow you to do that. I mean, you might see like all the stars instead of the IP addresses and all those things. You can do that. You can try to do the full path, but it will not. I mean, the the ISPs in mid will not give their IP addresses and all the information. But you try it out yourself so that you can understand. Okay, let's try to access. It's taking some time here. Ashok, if your interest is on sessions and cookies and all those things, I mean that you need to do it at the database level, because we are talking about the servers, right? If that server is goes on, like basically the session state will store in the same server itself, so that will also goes on. So if you don't want that to happen, what you can do is you can basically store the session information in the or cookies information in the database, so that I mean, it will check with the database and it will do that. Now you can see it's came back to, I mean, sorry, it's went to our secondary server. Let's try here. Now you can see, let's try from different locations, and you can see it's going to our secondary server, which is in our case it's London, right? So if you access from any other location, it's the same story. It will always go to the secondary server, as because our the primary server is down. Let's go and start the primary server instance state and start. Now what will happen? So in RDS, what is actually happening? You would just try to compare in RDS. So when you have multi-AZ enabled, let's say, sorry, when you have multi-AZ enabled, right? So if you have primary instance and secondary instance, you have an endpoint here. That endpoint will be mapped to your primary server, right? So when you have multi-AZ enabled, like this is how it will be. So when the primary is down, what will happen? The endpoint will be mapped to here. So this will be your new primary, and AWS will create one more secondary. It might be, right? It will create one more secondary in the place of fault primary instance. But here it is not like that. So when you have two instances, let's take an example, your primary and secondary. So the website something will come back to here, and if that is down, it will go here, right? But if it is came back after some time, let's say we have created some CloudWatch alarm notification, so that once the server is down, we'll get some notifications, or maybe you are using some third-party monitoring tools, right? Like yours or whatever it is, right? So New Relic or Datadog. So a lot of third-party tools available. So if you're using any of those third-party tools, and it will give us an notification, right? Send us an email or message, text message when the server is down, and we go and restarted the server. So now basically it is running now. So when that is down, the request went to secondary. But once it came back, then what will happen is that, so Route 53 will make the request go to the primary. So it means if the primary is running, it will always select or route the traffic to the primary, right? So this is how basically it will work. Now let's go and see that this is instance is like started. Let's go and see the health check as well. Let's wait here. Mumbai, it's still unhealthy, but it's taking some time. Okay. Now there is one more record type. I don't want to go through it now. What I can do, I will give you a brief what is that record is all about, right? You go and practice yourself, right? But I will brief it. Okay. I mean, I will explain what is that record. Is the last one, which is newly introduced actually. So it's around a year or something like that. So I'll give you an idea so that you go and practice instead of I'm telling everything. The one is called multi-value answer. Okay. So multi-value answer. So what is this multi-value answer, please? So what we have discussed uh, in the DNS, right? In the DNS. So what we have discussed, when somebody is browsing some domain name, right? The request will go to the DNS, and the DNS, what it will do in return, it will give the IP address, right? It will give the IP address. So, but when you have multi-value answer, when you are using this multi-value answer, so what will happen is that, so you can use this multi-value answer to map some domain name. Let's take an example, www.gravenlabs.com. You can map it to around 12 IP addresses. You can map it to 12 IP addresses, means you can map it to 12 servers. You can map it to 12 servers. Okay, now I mapped it 12 servers, and while mapping we have the option to select the health check. So we selected the health check. So we have to create basically 12 records, right? So we have to create 12 records, select multi-value answer and specify one IP address, then select the health check respected one. This one, next record, select that specified, that respected health check. It's like that. You can create up to 12. You can create it. Okay, now you have created multi-value. Now your, if somebody browses your www.gravenlabs.com, right? So you can create less than 12 as well. The maximum is 12. It's like, that's what I'm saying. Okay, now when you, when your user browses, when your user browses the domain name which is configured under the multi-value answer record. So what actually DNS will do is, so normally what is the DNS function? When somebody browses a username, it will find the IP address, right? And it will give that IP address. But now here, what is the difference? The difference for the multi-value answer is that the multi-value answer record is there. So instead of giving a single IP address, what it will do is it will give around 8 IP addresses. It will give around 8 IP addresses from the 12. So from the 12 servers, it will give 8 servers IP addresses, and to this 8 IP addresses, what it will do is it will give the 8 server IP addresses which are healthy only. So if all 12 are healthy, it will just randomly pick. So if only few are healthy, then it will give 8. So up to 8, this is also, it's not exactly 8. So up to 8 IP addresses, it will give it to your client, whoever is browsing www.gravenlabs.com. So basically what it is, it will be in your laptop or desktop, you browse that site, right? And the DNS gave, Route 53 gave you the 8 server IP addresses. So what is the use of 8 server IP addresses? At any point of time, you can get your data, you can get the data from one server, right? So why this will be useful is basically, let's take an example. Now we have 8, now the your laptop has 8 server IP addresses. Then what it will do, it will pick automatically one server IP address and it will get the content from that server. Out of one server, it will pick one, randomly it will pick one. There's no specifications, randomly it will pick, and from that server it will get the content and display in the laptops or the desktop, the user's machine. Okay, this is looks good, but still you might have kind of a question like, what is this? Why we need multi-value answer here, right? To better understand the exact reason behind it here is that, let's take an example with, let's say, the latency routing policy, or maybe okay, weighted routing policy, whatever the routing policy. Let's take an example, and I've called it Mumbai server. Let's say I gave 5, London server 2, North Virginia server 1. I have given the weight, right? Now when somebody browses the same, let's say here, somebody browses this website, then what will happen? Whichever is the highest weight, it will forward, right? So now the Mumbai is basically the highest rated one, so it will give the Mumbai server IP address. The DNS will give the Mumbai server IP address. Now what it will do, once the DNS gave the IP address, my browser, my laptop will try to connect to that server. Okay, but after Route 53 gave the Mumbai server IP address, right? And while it is trying to connect, because of some reason, that Mumbai instance is down. Because of some reason, whatever the reason is, right? So while giving the record to the laptop, the instance is working fine, but after giving the IP address, this is down. Now what it will do, laptop doesn't knows that, right? So it will make a request to the server, and the server is not working. So what will happen, we will get an error here. Obviously we'll get an error because DNS gave the IP address and it will try to contact. If it is not working, then nothing will happen. It will obviously get the error, right? So now here this multi-value answer is basically kind of a different. So what is that difference is that now here it is not giving a single IP addresses, right? It is giving up to 8 IP addresses. So it's giving up to 8 IP addresses. Now, while it will select and then try to connect to that server. If that server is not working, what it will do, the laptop will not go to the route 53 again because it has given already 8 IP addresses, right? So if one is not working, then it will pick one more from this 8 pool and then it will try to connect to the another server. If this is also not working, it will come back here and see there is one more, and okay, this server is working fine, it will get the content. So you'll not get the error page anywhere anymore. So this is what basically the multi-value answer is capable of, right? So do it by yourself, do some practice, right? So that you can understand better about the multi-value answer. I don't want to create it, right? So you practice yourself. Okay, let's come back to here. The failover routing policy we have created. Let's previously we went to Europe, right? Let's go and refresh. Now you see we came back to this ICOM Private Limited, which is basically what? The WordPress, right? Now you can see it's came back. So this is what basically. So as long as the primary is up and running, it will always go to the primary. When the primary is down, then only it will go to secondary. Okay, it's right. So this is what basically the failover routing policy is all about. Now we have discussed about the uh, geolocation routing policy as well, right? The geolocation routing policy where we have mentioned the India, right? We have mentioned India as a country, and then Europe as a country, sorry, continent, and North America as a continent, like this. Okay, so the name I have given as media. So if anybody browse from India location, they will be routed to Mumbai server. If anybody from Europe, they'll go back to London. If anybody from North America, they'll go to North Virginia. So let's explore that by just simply entering media.gravelabs.com, right? So media.gravelabs.com. Now you see it's trying to open the ICOM Private Limited page, which is a WordPress page, which is hosted in Mumbai. So let's copy the same website and try to access from Europe. So here we have the proxy site. We can select Europe locations, right? So let's select the Europe one, some EU one. So it's a Europe location. So we are basically trying to connect from the Europe location. Now you can see that it's went to Europe. Okay, let's select one more and try to connect. Again Europe. Let's go to United States location, which is in North America. Let's go there and see. It's going to what? This site maintenance phase, which we have mentioned in the North Virginia instance, right? So if we try to access from any other US location, it will go back to the same that North Virginia instance. Got it? Understand like what is geolocation means? Okay. Now there is a question for you here. Now here I have an instance in Singapore. Okay, and I already connected it. This is my Singapore instance, right? Now I'll try to connect from here. So basically what I'm trying to do, I'm trying to connect to this media.gravelabs website from the Singapore location, right? It's created in Singapore. So now what will happen? So for India, I did this mapping. For Europe, I did this mapping. For North America, I did this mapping. Now what will happen if somebody browses from Singapore? Any guess, guys? So you say Mumbai is nearer, so it will be routed to Mumbai. Is that what you're talking about? Okay, let's see that. Let's go and refresh. So sorry, let's go and enter and see. You see what happened? We are not able to access. right? So why? Here is that if you see Singapore, we have not mentioned for Singapore any record. Did we mention anything for Singapore? No. And Singapore is in Asia, right? It's an Asia continent. Did we mention for any Asia here? No, I have mentioned for Europe and I have mentioned for North America, but Singapore is not in Europe, neither in Europe nor in North America. So obviously there is no record for Singapore. So what will happen? It will not connect. So this is what geolocation means, specific. If you want only few countries access your website, then you go with your geolocation. So other country users will not access the website. If they enter that website also, they will not be able to access it. They'll get this page same like this. They'll not connect the website. So the same URL, if they access from India or maybe United States, it will work, right? And if you are accessing from maybe from China, Pakistan, or Afghanistan, or maybe from like the Singapore or like this, and they will not be able to access. So this is what geolocation is. So you can make your requests should be came to your application or website based on the geolocation, the specific. So let's say if you want to create a website for only India, simple, create only record for the India users, which means geolocation set to only India, so that no other country users can come and access your website. They'll all get the errors. They'll not be able to access. It's like that. And there is one more option here, which is called, while creating the this geolocation here, there's a simple option here, which is called a default will be there first. Default. So what is this default means? It's simple. Right now I have specified these three locations manually, right? Now let's say I created one more server, which is in, let's say, in Paris region I have created. And then you can select default. Let's say you can select a default as the option in the geolocation. So what does this default means, right? So if anybody from India, they'll come here, from Europe they'll come here, for North America they'll come here, right? Same like now if somebody access from Singapore, then what we have seen that they'll not be able to access. But when you have default policy, I mean in the geolocation, when you have default setting, what will happen is basically is that right now the not specified countries or the continents, the users from not specified geolocations will come under this default rule. So like Singapore, they'll go and the request will go and land in Paris server, and then they'll get the content from Paris. But that will only work if we have the default record. If you have created previously, we didn't have created, right? So this we have not created previously, so that's why Singapore didn't get any access. But now if we create default and do it, then obviously it will connect to some other server. So this also you go and do some practice so that you can understand. I don't want to do it, right? So this is what basically is all about the route 53, right? So now here there might be, you might have like some questions, right? Regarding, now we have around like 6 policies here. It is only mentioned one, sorry, 5, but we have like around 6 routing policies are there. So at what point we need to select which policy? So which policy should I need to go with, right? So it's basically based on, as I told in the previous session already, it's based on purely on the requirement. So for your requirement, which routing policy it may fulfill, then you can go and stick to that. Let's say you need kind of a high availability, but you don't want to create multiple servers. You can go with failure routing policy. Primary one server will be there and secondary one server will be there. So if primary is down, you create in one region primary and create one secondary in another region. Same like I've created in Mumbai and London, 2 different regions. right? So if whole India is down, still you don't need to worry because there is one more server in London, right? And then it will take care of the request. So you can have high availability across the regions with a simple routing failure routing policy. It's like that. So it's based on the requirement. I mean, whichever you want. You want low latency to the users, or if you want geolocation specifics, right? If you want like multi-value answer kind of a requirement where even you don't want any kind of a errors and downs even within that after DNS responded, if the server is down, you don't want your request to be fall down. I mean, you don't want your users get that error request and all. You can go with the multi-value answer. So it's up to you, right? So whichever is basically the requirement. I mean, that's what I'm saying. Whichever there is no specific or there is no standard. So based on the uh, requirement, we can go with it. So each has its own advantages. Weighted has some, latency has some. So which advantage you need, then you can go and select. That's it. Or maybe you're not the one who can take the decision. Then you might have your team leaders or managers or your project managers, senior project managers, like you'll be having all the people. So you can specify them. So these are all the option we have in Route 53. So this is like this is like this is like this. Take a give them the idea like what this all the different routing policies all about. So then they will understand, okay, this will work like this and this will work like this, and based on that they might take the decision instead of you. So you're basically giving them the options, and from that option they will pick one and you can go and implement. It's like that, right? Cost wise, simple cost wise, I mean, you go and what we can discuss, it's nothing to discuss. Let's click on a search for Route 53 pricing and it will give. Now you can see if you want to host at a zone, this is what I mean when you create it, right? So first 25 hosted zones, this is the cost, and if you are using more, this will be the per hosted zone. If you are using more, they will like less the amount, and the first 1 billion queries per month is the cost, and if it is more than that, then this is latency based routing, this is the charge, and geo policies and all those things, this is the charge. It's like that, right? So let's and if you can see the health checks is where here you can see health checks is this is the cost for it. So basic health check, like per health check it will be like 50 cents per month. If it is an AWS endpoint, which means if you are pointing to AWS server or AWS load balancer like this, or if you are pointing to a server which is not in AWS, then it will be a cost is more. It's like 75 cents per month. This is like that simple. Okay. So the pricing is simple, very simple. You just go there and see. That's what the pricing is all about. Now, this is what basically the uh, Route 53 is all about, right? And let's go and start the one more important topic, which is called building VPC, right? So this is basically kind of like what we have. It is a continuation of what we had the discussion on VPC part one, right? So we discussed uh, the networking fundamentals in the offline video recordings, and then we have discussed about the um, you know how we can create a VPC using that option of VPC wizard, and we understood public subnet, private subnet, and all those things, right? Now we are going to discuss in detail like why public is behaving like that and why private is behaving like that, which means when we have an instance in public subnet we are able to reach, but when we have an instance in private subnet we are not able to reach. So what is that reason why it is not happening? And also we have created the VPC structure, the architecture using the VPC wizard. right? That is only to just give you an idea to the VPC. But actually in the organizations, that is not the process we follow. What we follow is basically what we are going to discuss now. This is a process we are going to follow, right? Now we'll create the VPC architecture step by step, right? So it's like that. This, say for example, zone wise hosting might be costly due to servers. See, zone wise means I'm talking about different domains, Rupesh. Here hosted zone means hosted domain. So if you have like multiple domains, that is, I mean, if it is less than 25 domains, there is a cost. If you have more than 25 domains hosted on AWS, then it's a different cost. It's like that. Zone means domain. Okay. Okay, guys. So prior we starting this VPC concept, right? So let's take a break for 10 minutes, and once we come back, we'll go and start the VPC, and we'll see like how we can create and all those things. We'll go and discuss. Chalo, guys. Have a break. We'll come back after 10 minutes. Thank you. Welcome back. So let's get started with the VPC building, how we can actually architect the VPC and all. Okay, let's first go to the VPC console to start creating the process. Let's go to VPC. So it will be under, let's search with VPC here. Okay, open in a new tab. Okay, now you can create anywhere. So let's go with the, I think we have, I'll go with Singapore. So anything is fine, which it's up to you. Like whichever is good for you, you can do it. So when you go to any region and you click on your VPCs, there will be a default VPC will be there, right? So default VPC will be there. That is by default created by AWS when you sign up for the AWS. And these are default VPC. So when we create databases or load balancers or instances by default. So with the default settings, all will be created in this network, right? In this VPC. Now we understood like what is VPC basically means. It's a network, right? And we understood what is a subnet is basically it's a sub part or a portion of a network. We call it a subnet. So that we have discussed it. And then we are going to discuss in the in the same VPC, we're going to discuss some more components as we go through this session, which is called internet gateway, route tables, and network address translation instances. I mean, NAT instances are NAT gateways, right? So, and if possible, we'll try to see the network ACLs, NACL in short, we call it as. So these are all the things we are going to discuss in this today's session. Okay, and in the previous session, what we did, we went to the VPC dashboard and then we clicked on uh, VPC wizard, right? So in the VPC dashboard, we clicked on this launch VPC wizard. That is basically kind of a template. I mean, it gives us an options to create the VPC in a simple way, right? But we want the hard way of doing the things, not the simple way. Okay, let's do that hard way of creating the VPC. So let's go to first VPC. So the first step, so it will be a step-by-step procedure to create the VPC. Okay, and the first part, or you can say the first step, there are 4 steps will be there, right? Or you can see the 4 components, right? And the first step is basically will create the VPC. Okay, and then in second we'll create the subnets, because obviously subnets we cannot create first, right? Because subnet is basically part of VPC. So always the first step will be VPC. First we'll create the network, and then in that we'll do the all the architecture. Okay, and then to make it private or public, all those things. So there are 2 components actually play the important role, right? So if the subnet is a public one or if the subnet is a private one. So those 2 components are route table. Oh, sorry, maybe I'll give here internet gateway and then route table. So these are all the 4 components. Okay, so we know VPC and we know subnets. First, let's create those things, and then we'll come back to this internet gateway and as well as the route table, and we understand what is that and all. Now, here I have created a PowerPoint presentation, which basically gives us the idea of like how we are going to do this building VPC, right? So I have created like this paper presentation so that you can understand PowerPoint presentation so that you can understand like how things will work here. So all these things you might understand, like what is going to work and how is going to work. So these things will do it. So we will go through this diagram as we go through the process of creating or architecting the VPC. Now this is the process. First we'll create the VPC, and then the second step is basically create the subnets, as I already told, and then the third step is internet gateway, and the fourth step is what? Create route table. That is the route table. And then the fifth step we'll discuss later. Once we understand the things, we'll discuss. Okay, now let's go with it. First we need to create a VPC. So to create a VPC, what are the things we need? So first thing is that we need to choose one IP addressing scheme. In IPv4 we have like class A, class B, class C, right? So in that we have to select one IP addressing. Anything is right. So you can go with class A or class B, class C, anything. You can go with any IP addressing. So if you take class A, we have a whole 10 network. When we go with the class B, we have like 170 to 16 to 170 to 31, wherein C class 1 and to 168. So that we already discussed in the networking fundamentals, offline recordings, and all those things. So let's select one. Anything is fine. I'll go with okay. I'm creating in Singapore. You can create anywhere. The process intact same. Nothing will difference. Okay, let's go to your VPCs and click on create a VPC first. Just click on it. And here there are some options will be there. We'll discuss what are those options. First is name tag, just a tag. Whatever the requirement you're creating for, right? For which client you're creating for. So you just give that name. Let's say I'm creating for my client data marshal. Just take an example, okay? Right. Now data marshal, let's say there are like I want like this VPC should be for, let's say, development environment, not for all the things. Okay, now I'll say that okay, dev. So data marshal dev. So this will be basically the a network for development servers, development applications, development databases, load balancers, all the things which are relevant to development. So by seeing that name I can understand, okay, it's a development VPC for the data marshal client. Okay, now here we need to specify the CIDR blocker, which IP address we are going to use. Okay, so whichever is fine you can go with. Now I'll go with, let's say, 10 dot let's say 10.10.0.0 slash 16. So you can go anything. So you can go with 10.1, 10.20, 10.30, whatever is fine. I mean, it's up to you, like how you want to create. So now I'm going with 10.10. So 10.10 slash 16 means what basically? So this will be the network portion by default. So we have two more octets left. And if you want to do the subnets, the sub part, the subnetting, how we can do it? We can use this third one, the third octet, to do the subnetting. So we can make that as a network bit. And then we can, like, how many networks we can create from 0 to 255. So total 256 networks we can create, means 256 subnets we can create. Okay, I don't want to go with any IPv6. IPv4 is what we require now. And then tenancy. So what is this tenancy basically means is that, so if you see like what we are creating, as I told, we are, while creating the VPC, like we are creating VPC, we are creating subnets, and we are creating, in the next step we'll create internet gateway, route table. So these are all basically the devices. Like this is a gateway, this is a router, right? Though this might be a switch, something like that. So whatever we are doing is basically we are all creating switches, hubs, right? Gateways, routers. So these are all devices, compute, the networking devices, right? So these networking devices, if you go with tenancy default, it will be like virtualized, same like our virtual servers, how an instance is virtualized. We discussed in the virtualization part, right? So the same way, when you go with tenancy default, your router will be virtual, your gateway will be virtual, your subnets and everything, your switches, hubs, everything will be like basically virtual. But if you don't want the virtual device, you want physical one, then you can go with dedicated. So dedicated means basically we have discussed virtual, right? So on the same physical box or the physical machine, you will be having virtual different virtual things. So on a physical server, you might have 5 virtual servers. But when you go with dedicated, what will happen is that, so that the physical machine or the physical gateway, physical router will be dedicated to you. So AWS will be providing the dedicated resource to you. But remember this, when we select dedicated, it will be chargeable. So by default, as we discussed in VPC, whatever we discussed till now, it's free kind of, right? We create the architecture and all those things. It's kind of free. I mean, it's not like everything is free in VPC. There are some cost effectives are there, which we'll discuss. Right? But when you go with dedicated, what will happen? Everything basically kind of priceable. So everything is cost effective because we are asking AWS to provide dedicated resources, right? So that's fair. So I mean, if you want kind of a requirement where you want dedicated resources, go with dedicated. Otherwise, default is fine. So there is no difference if you go with dedicated or default, it's the same. But you'll be having your devices. That's the only difference. Okay. And let's click on create so that we are creating. Now we have created the VPC. The following VPC was created. Let's click on close. Okay. Now we have created the VPC. Fine. Right. Now the second step is what basically we have to create the subnets that we know. But what I do, let's go that there are 2 servers running. So I'll remove these servers. Let's say I don't want these to be running. I'll terminate these instances. Okay. Now we have just created the VPC, right? Okay, data marshal VPC we have created. So let's try placing an instance in that. Let's try placing an instance in this. Let's try to do that. Go here, launch an instance. Any instance is fine. Let's select one instance, and T2 micro is what we need. And then here, what we'll do, we'll select the VPC data marshal dev. Okay. Now you see here, there is an error came up. What is saying? No subnets found. There are no subnets are found in VPC, and that's why you see that a subnet is required when launching into a VPC. Means when you want to create load balancers or databases or EC2 instances, anything in VPC, you need at least one subnet. You need at least one subnet. So without a subnet, we cannot create the resources. So that's why we need to create the subnets. Okay, let's go there and add the subnets. The next step. Let's go there to the VPC. And now this is what the dev VPC, right? So now let's go to the subnets here under the VPCs. So there will be some default subnets will be there. These are all basically for the default VPC, right? The default VPC subnets. So let's make it default so that we'll understand. It's a default VPC. So when you go to the subnets, we see that it's a default VPC subnets. Okay. Now let's create a subnets in our VPC. Click on create and specify the name tag. Let's say give some name, any name. Let's say I want, okay, data marshal. I want this to be a public subnet. I'll just made it as public subnet. I name data marshal public subnet. Okay, in which VPC I want to create? I want to create in this VPC. Okay, and this is, we already discussed availability zone preference, right? It is much important. So when you're creating the subnet, we'll select the, or we'll specify the availability zone. So while creating the instance, we'll not select the availability zone, wherein we'll select the subnets. So based on the subnet, so wherever that subnet is, I mean, whichever availability zone the subnet is located, our instance will be created in that availability zone. Okay, let's go with, we have like 3 availability zones here. Let's go with anything is fine. This one, AP Southeast one availability zone, and which one you want. Okay, 10.10, this will be the network portion. From there 0 to 255, you can use any number here. Let's say I will start from, let's say 1.0/24. So what is this 1.0/24 means? So the first 24 bits are the network, so which means I can use the whole last octet, which means how many instances I can place 10.10.1.0, 1.1, 1.2, 1.3 up to 1.250, 255, right? So you can have up to 1.255. So total 256. But AWS use 5 IP addresses within that 255. So we can have, sorry, 256. Right? So total is two. I mean 0 to 255 means we need to add 0 as well, right? So total 256 minus 5 will get 251 IP addresses. They'll use for gateways, routers, and DNS, DHCP, all these things they will use. AWS will use. Okay, that's one. Okay, let's click on create here. Now we have created one subnet. We named it as DM public subnet. Great. Now let's try to launch an instance. Sorry, we have created one subnet, right? Let's create one more subnet. So I'll follow this diagram. Okay, let's go there, and we have created this public subnet. Let's go and create one more subnet. We call it as this time private subnet, let's say. Okay, DM private subnet, right? Okay, and which VPC? Obviously data marshal dev VPC. And I've created one A, right? Let's create in one. So I think I've created in AZ1 or 2. I'm not exactly sure. Let's go with AZ3, let's say. I'm creating one C here. Okay, these two different availability zones, and cider black 10.10, and let's say start with 2.0/24. So this will be from 2.1, 2.2, 2.3 up to 2.255. Let's click on create. Okay, now we have two subnets in that VPC like this. Let's launch the instance, and where I'm launching in the subnet one means, let's say I launch it in the public subnet, the first subnet which I created, right? So let's go and create an instance in public subnet. Launch instance. Now I'll create a Windows one. Okay, I'm selecting Windows one. So we want to go with the T2 micro, obviously, otherwise we'll be charged. Okay, here I'll select the VPC. Previously, when we have selected previously in the previous step, we got an error because we didn't have any subnets, but now we had subnets. We have two subnets, right? So let's click on this public subnet. So when I click on public subnet, in which availability zone it is? 1A availability zone. So my instance will be in that availability zone. So do I need public IP or not? Yes, I need, let's say. So I can go and enable it. Okay, I can go and enable it, and remaining all will not worry much. Let's go with the remaining things as default. Add storage, add tags. Let's give some tag. So data marshal dev. These are dev VPs, right? So let's say public server. Give that name. Okay, configure security group. As we discussed that when you click on select existing security group, will not have any security groups because it's a new VPC. So security group means what? It's a firewall. So we have to create the firewalls as well. So we'll name it as data marshal dev Windows firewall. Okay, review launch key pairs. We don't need to worry. We can use a key pair, the same key pair across the VPCs. I've selected that auth key which I have, and then I have launched. Okay, now it's creating the instance. Great. Now we're creating the instance, right? Let's try accessing that instance. Now we have created the instance. Okay, am here is there. Let's say this is me in green. Now I'll try to connect to this instance. So we have created VPC, we have created subnets, and we place an instance, right? Now let's try access this instance. So remember that we have enabled ATOS in public IP, so it will have the public IP, right? So if we didn't enable that, what will happen? If I didn't enable the ATOS in public IP, it will have only the private IP. So with private IP, obviously you cannot access the instance, right? So private IP scope will be within the VPC, within the network. Over the internet, if you want to connect, obviously you need a public IP address, right? So but we have enabled that, so public IP is there. Okay, subnet 1A is one availability zone. Yeah, think yes. Okay, let's go and access this instance. Okay, this is the instance which is there. Okay, so it will take some time for it to, I think, get the password, but let's try connecting with an IP address, MSTSC. Let's try to connect. So we are trying to connect here. We're trying to connect. We're trying to connect. Now you see what happened. We have not able to. We are not able to connect. Okay, there is some issue seems to be. Okay, what is that issue? Why we are not able to connect? We didn't connect it, right? Now here, what is the story? Why didn't connect it? And I've placed in public subnet only, right? I made that as a public subnet. I mean, I named it as a public subnet. So when I discussed in the previous session, I mean the previous VPC part, when I say public subnet instance, we can able to access over the internet, right? But here it's not working. So the thing is, when you give the tag name as public or when you give the tag name as private, it will not be public or it will not be private. 1 second, guys. 1 second. Okay. So made when we give the tag name as public or private, it will not become private or it will not become public. We'll understand soon why I'm talking. I mean, why I'm telling, make a note of this. Okay. So now let's discuss this, why we are not able to connect, right? So take this scenario as, let's take an example. We have this VPC, right? So this is the VPC I told. I've just created that rectangle, seems like one, right? Now think this box, the outer box, the VPC as a big compound wall. Now these subnets are, let's say, two homes or houses. So there are two houses in this compound wall. Now this instance has taken example as one person. So one person sitting in this house. Now I am here and I am trying to reach this guy. So if I want to reach this guy in this house, what I need to do? First I need to come into his house, right? Means I need to enter his house. How can I enter his house? Basically I need to enter into this compound wall. So basically I need to enter into the house area, his area, right? So what normally we'll be having in at the compound wall, at some place they'll be having some entrance and exit point, right? So you'll be having the gate for your home. For the compound wall you will be having some gate, but here do we have any gate here to entrance to enter into this house? I mean to enter here. So once we enter here we can go to this house and we can reach this guy, but it's a closed VPC. I mean it's a closed compound wall. How we cannot jump. Now what we need a gate, right? So we need a gate. So now in the terminology, in the networking, what is that gate is basically called as gateway. We might listen this word gateway, right? So what is basically gateway means? It's an entrance and exit point for your network. It's same like a gate which is basically will be in your compound walls. So if somebody wants to enter, right, they will enter through that gate. If somebody wants to come out, same in this with the with using that same gate they will come out. So go in and come out. It's basically an entrance and exit point. So this gateway is also the entrance and the exit point for your network, and that gateway in VPC, in AWS we call it as internet gateway. That VPC we call it as internet gateway. Okay, now what we'll do, we have created VPC and subnets. Now we'll go and create the gateway. Let's go and do that. Go to the VPC where we can create the gateway. Now you can see this is internet gateways. Let's click on that. So we have already one gateway is there, and you see the state that is attached and to which it is attached, and you see that it's VPC default. It is attached to the default VPC, which means it's the default VPC gateway. But we want that gateway for the data marshal dev VPC. Let's click on create an internet gateway, create a name tag. So DM dev gateway. Okay. So in the previous step, when I'm creating subnets, there is an option to select in which VPC do I need to create. But you see that while I'm creating this internet gateway, there is no option. Just where only one option is there. That is, I just need to give it name tag. But after click on create, so in which VPC this will be associated, right? So the thing is here, while creating the internet gateway, we will not associate with any VPC. After creating, we'll associate. Okay, let's click on create. I just give the tag name. That's it, nothing else. Click on create. Okay, that following internet gateway was created. Let's click on close. Now you can see the internet gateway we have created. You see the dev DM, and what is the state? You see detached, means it's not attached. Okay, and we'll select that gateway, go to the actions, and you see there is an option called we can delete it, we can attach, detach, and add edit tags. So which one we are interested in now? Attach to VPC. Click on that, and here we can select the VPC. Now here it is showing only one VPC. We have two VPCs, right? Data marshal one and the default one, but it's showing only one here. Why? What is the reason? To understand that reason, let's go there and do a simple story and simple thing. What we'll do is select this one. This is a default VPC internet gateway. Okay, and detach from it. Okay, now I have detached this gateway. Let's go to our dev VPC, sorry, dev gateway. Let's go and attach. Now if you select, you see what happened? Now it is showing two. The reason is, okay, so I'll select this one anyway, the data marshal one which I want. I'll select that VPC and attach it. So the basic why, the reason is that for one VPC there is only one gateway. So I'll attach to the default gateway to the default VPC, right? So one network you'll be having only one gateway. You can have multiple, you cannot have multiple gateways. I mean, for a house, if you have a compound, you can have an entrance one, exit one, kind of. You can have multiple, so different homes, different gates, and all. It's up to you. You can do it, but in network, it's not like that, right? So you can have only one gateway. So we have created gateway and attached, right? So we have done that. Now let's go and try to access the instance now. Let's try and access the instance. Now we have the gateway, right? So let's go and reach the instance. This is the IP address. Let's go and connect. I'll see what will happen. You see what happened? Still we are not able to connect. Why? What happened? Again, we didn't connect it here. We have VPC, we have subnets, we have created the instance, we have attached, we have created and attached the internet gateway. We did the three part, but it is not possible. Okay, so why? Let's try to understand first why it's not happening. Then we'll go to that, the fourth thing, route table. Okay, now when we have a gate, so the when user is trying to access the instance, when a user trying to access the instance, what will happen is basically the request will come here. The request will come here till the gateway. Now from here, the request should go to here, right? So from here, the request should go to here. But the thing is that who will tell or who will guide this request to tell, okay, you're trying to reach this instance, right? And this is instance in this subnet. Who will guide? Who will say that? So normally, let's say when you're going by a vehicle on road to from some location to let's say you are going from Bombay to Mumbai to Delhi on road. So let's think like you don't have any technology in your hands, like you don't have any smartphone where you have Google Maps or iMaps or some maps and all, right? And you are the only one who is traveling, and you didn't went on road from Mumbai to Delhi. This is the first time you're going. How you do it? How you go normally, right? So it's like you start the journey and you go there, right? So people will say that this is the Delhi highway, this is Bombay highway, this is Hyderabad highway, Bangalore highway, something like that they say, right? So means that is the highway which we need to take to reach the destination. Okay, we take that path, but that path will have a lot of lefts and rights, a lot of junctions, a lot of crossroads, right? So we'll be in some kind of a where there will be some all four roads will be there, right, left, straight and back. So which one we need to select? Who will help us? If you have Google Maps, that will help us, but forget about the technology, right? So normally on the roads, on the highways, you might see the boards will be there based on your country. If it is in India, it will be there in the left side. If it is in some other maybe country, it might be in there in right side also. So what they will do, or maybe in the top of the road, like a command is also they will do it. So where it will tell you so which route you need to take, like left. If you take left, you'll go to somewhere. If you take right, you'll go to somewhere, and this is a distance, something like that. They will give us the destination and the path. So they will guide us to reach our destination, right? So here also we need some kind of that to give us an idea to reach our destination. Now this instance is there in this home, but how can this request knows that? Is it here or is it here? How it will identify, right? So to do that, we need the that that what that one more device which is called the route table. So basically in the network terminology, I mean in the normal standard network, traditional networks, we'll be having the router. We'll be having the router. Okay, that router is basically, you see that router has the way, I mean has the word route or route. So what it will do, it will gives us a route, basically simple, right? It has a route in that router word, right? So that basically do it. So it will basically give us the path to reach the destination. So that router here in AWS we call it as what? Route table. Route table means nothing, it's just a router. Okay, now what we'll do, we'll create a router. Next day what we'll do, we'll create a router. Okay, let's do that. Go there to here, VPC. Let's go and go to the route tables. So the default VPC route tables will be there. Okay, what we'll do, we'll create a route table, give a name tag. Okay, DM dev. I call it as, let's say, public one. Let's say I'll say public router or something like that. I'll say. Okay, here we don't need to worry about like internet gateway. So while creating itself, we have the option to select in which VPC you are creating. I'll select data marshal. Okay, and we have created, and I have named it as public router. Okay, remember this name. I'm just naming it. Click on create, and the router has been created. Okay, a router is created. Perfect. Let's go there, and now we have placed the router. Okay, let's try accessing the instance again. Let's try accessing the instance again. So we have the router now, right? Let's see, it should connect now. What do you think? We'll be able to connect? I think we have all the components, right? Why? Why it is not working then? So we are not able to reach. We have the routing table that I have created here. That routing table. Okay. So here, so when we create a routing table, by default, it will have a default route. If you select that and if you select a router and go to the routes here, if you go and see the routes, it will have only a local route. It will not have any other routes, which means by default it can handle the local traffic. But this request is basically coming from where? Coming from the internet. So it is not a local traffic, right? It's an internet traffic. So by default, when we create the router, that router doesn't have any idea about the how to handle the internet traffic and all, and how we make this router to handle the all the traffic. How we can do that, right? So that is a last step in building the VPC. I mean the traditional VPC, you can say that. That is what basically what we need to do. We need to communicate, or we need to connect. Okay, so what we need to do basically is that now this is the picture here. So we have the router and all, but by default when we place the router, what will happen? We'll not have any routes. So what we'll do is this one will basically this route table kind of a mediator, you can say that. Okay, so using this route table, what we'll do, we'll connect the gateway and then we'll connect the subnet. We'll do the two changes here. We'll connect from the route table. It is like a midpoint. Okay, from the route table, we connect the internet gateway to take the request from the internet, right? And then it, if any request is coming and going internet, what it needs to do, it needs to forward or take from the subnet, right? From the instances where the instances will be in the subnets. Now what I'm doing, so I'll connect the router to the subnet as well. I'm not connecting to the instance. Remember here, I'm connecting to the subnet. So I'm basically using this route table as a midpoint to make these connections, to have a path, a proper path. Now let's go and see that. How we can do it is first do this gateway to routing. This first this connect this one. So how we can do it? So in the routes itself, in the route we have only default route, right? So it can handle only local traffic. Let's click on edit routes. Now what we'll do, we'll add a route. Now what I want to do, so internet traffic means that is coming from any IP address. That is coming from any IP address, right? So how can we specify all the IP addresses? The what is the wildcard, right? 0.0.0.0. So any IP address. So to where we need to do that? We need to the internet gateway. So select the internet gateway here. Select internet gateway. So we have the internet gateway is this one, right? So these are DM dev gateway. Select that. Now what I did, I have associated the route saying that okay, any traffic basically coming from internet. So take the traffic coming from internet gateway, both the sides, input or output. Okay, let's click on save route. Route successfully edited. Click on close. Now we have the two routes. Okay, now it can handle the internet traffic using the internet gateway. Okay, so we have this one is done. Now we need to create this path as well. So how we do it? Simple. Here you can see there is subnet associations here, right? Click on subnet associations. Now if you go and see that this router is not associated with any subnets now, because when we create a route table, that will not be associated with any subnets by default. We need to make it. What we'll do now, that edit subnet associations. So how many subnets we have? We have two subnets here. But which one I want? Let's say I want the public subnet. I named it as a public subnet, right? I select this one. I'm not selecting the other one. Okay, I'm selecting only one. Click on save. Okay, I did this one also. Subnet associations. Perfect. Now we have the path, full path. Now let's try to connect the instance. Let's try to connect the instance. Let's see. Now we have the full path, right? The request will come here. From there, as internet gateway is associated with the root table, it will go here. So from the root table, it will go to the subnet and then it will reach the instance. Now we have the full path. Let's go and see that. Now it's came. It's asking for the username and the password. We know the username is what? Administrator. Let's go and get the password using the auth key. So this is the password. Let's copy the password. Enter. Okay. Let's click on yes to connect. Okay. We are able to reach the instance, right? Now, if I once I connected to this instance, once I connected to the instance, if I try to reach the internet, I mean, I will open the Internet Explorer. I'll try to connect the instance. I mean, I'll open the internet. I will try to connect maybe Google, YouTube, something like that. Will I be able to reach the internet now? Guys, anybody? Any guess? Can I be able to reach the internet? Let's see. There's the instance. Okay. Click on Internet Explorer. Let's try to access YouTube or something like that. Okay, let's open youtube.com. What happened? So we're able to reach, right? We reach. Why it's coming? If you see here, from here I try to connect the internet. So how it will do first? From here, how it will know that where is youtube.com is? If you go to the VPC and router in the routes here, what will happen is that, so the instance will ask the router saying that I am trying to reach YouTube. Okay, so basically first it will ask the DNS. DNS will give some IP address. What is the IP address of youtube.com? Let's go and find it out here. Command ping youtube.com. So we'll get the IP. So what is the IP? It's 172.217.194.933. So this is the IP address of the google.com, sorry, youtube.com. Now, so it will ask the route tables. How can I reach the 172.217, some IP address? What the routes has, the route table knows that. So if any IP is starting with 10.10, then it knows that, okay, your destination will be in local. Your target will be in local. But that 172.217, it's not 10.10, right? Then we have one more rule. What it says, any other IP apart from 10.10. Then what it's saying, ask internet gateway. Ask internet gateway. Then what will happen? Using this path, the request will come to internet gateway. So internet gateway is what? It's basically the gateway for your network, right? Then from here gateway, the request will go to the internet and it will reach that 172.1 server, which is basically in some Google data center somewhere, and it will reach. So once we made these changes, this connection, both in, as I told, that internet gateway is like what? It's like both incoming and outgoing. Basically it's like entrance and exit point. When somebody entering into your home, they'll cross into the gate. When somebody is going out, they'll open the gate and they'll go out, like this, right? So this is what basically the how the network will be created, how the flow will happen. Okay, great, we understand now. Let's focus on the now we did these changes. Let's go with the subnet 2. What we'll do, we'll create an instance in subnet 2 as well. Okay, let's do that. Let's create one more Windows instance here, launch instance. We'll come to that, Sandeep, later. I will not say that now. Okay, I'll say this on select Windows instance T2 micro. So I'll select the dev marshal, dev VPC, data marshal VPC, and this time I want to select the other subnet, the private subnet which is in 1C, and I want enable auto assign. I need an auto assign enable. Add storage, add tags, name. Let's say DM dev. Let's say private server. I just made it as configure security group. I have already created one, right? Windows firewall. Let's go with this. Review launch. Launch. I'll use the same auth key pair and launch the instance. Okay. Now I have launched the instance. Okay. Now we have launched the instance. Let's try to connect it. Now tell me guys, can I be able to reach this instance? Why? Okay, that's right, Vijay. True. Any others? What is the reason? Exactly. True, Vignesh, right? Even Abhishek. Any others? Good. Sindhusri, right? True. So basically, we don't have any route, any path route to reach a destination. There's no route, right? So let's try and evaluate that. Is it really true? Let's copy the IP address here. Let's try to connect. MSTSC, enter, try to connect. We are not connected. Okay, okay, we didn't connect it. As I told, we don't have any route table, right? So that's why we didn't connect it. Let's place a route table. Let's place a router, a different router for this uh, subnet instance. I mean the subnet, private subnet. I'll create one more route table. Okay, I'm creating one more route table here. So let's go to here. We have a public route table, it's already there, right? Now what I'm do, I'll create a one more route table. This time I'll call it as a private router, let's say. In which VPC? Data marshal dev. Click on create. So when we first create a router, what will happen? What routes it will have? Local route, right? If you go and see that, it will have only a local route. And if you go to the subnet associations, it doesn't have. It will not be associated with any subnet associations. The same thing we already discussed. And let's what we'll do after we have created the route table, right? Let's make this small change. I will associate this route table with this subnet. I'm mainly only making this one. I'm not making this one. Okay. I'm not making this one. I will only do this one. Let's do that. Let's go to the subnet associations, edit subnet, and I'll select only the private one. Okay. Click on save. Okay. I only associated the private one, the private subnet, but root has only one local root. It doesn't have one. Now, if I try to connect the instance, will I be able to connect? Now I have router. Can I be able to connect? Why? So let's try accessing it. So okay, there is no connection between router and gateway, right? So that's why it will not connect. Let's see. We didn't connect it. True. You're right. We didn't connect it. Okay. If we make this change, okay. If we make this change of this one, what will happen? If I add this one, let's say, if I add this path, what will happen? What will happen basically is that right? So basically here, what is the difference between these two subnets now? Is there any difference? I mean, the way it is connected to the internet gateway. Now I had made this connection, let's say. If I give this connection, is there any difference? So if I have an instance, I can come this path and reach this instance. If I have an instance here, I will allow this path to reach this instance. So if you have a subnet and where you have an instance, you are able to reach via the internet. What is that what is that subnet? We call it as public subnet. Public subnet, right? But if we don't get this connected, then what will happen? This will not be public actually. This will be private. So what is my point here is actually the difference between the public and as well as the private subnet is only here. The subnet is actually connected to the internet gateway or not. If a subnet is connected, have a connection to the internet gateway, then it will be called as public. If a subnet doesn't have the connected over the route table to the internet gateway, then we can say it's a private subnet. So which is the device or the component is that distinguish between this public and private subnet? This is the one, the internet gateway, right? So if a subnet has access the via route table to the internet gateway, it is public subnet. Otherwise, it will be private subnet. So that is what basically the difference between the public subnet and as well as the private subnet. Understand what is the difference between now public subnet and the private subnet? Why we are able to reach the instance in public subnet but not in private subnet? Because we don't have the route in the internet gateway. There is no internet connectivity to this subnet now, right? Now we have the instance in subnet 2, right? So how we can connect? If you want to connect, we can connect via the subnet 1 instance because it will have the local route, right? So it can we can have the local route. So what we can do, we can connect to public subnet instance, and from there we can connect from subnet 1 instance to subnet 2 instance, and then we can access the internet. So what I'm trying to do now, I'll connect to the subnet 2 instance from subnet 1. Okay, now let's do that. Here I cannot connect over the internet, we cannot connect, right? So let's go there. So we'll try to connect from the, okay, this is the public subnet instance, right? Now let's open MSTSC. Okay, so now what is the, which IP address we need to use? We can't use the public IP, right? We have to use what? Private IP. I'm using the private IP of the private server. Okay, now let's enter here. So if I click on it, what will happen? It will asking the username and password. But how actually it is asking? What is the IP address I'm entering here? 10.10.2.170, right? So where I'm entering actually in the, I'm entering in the public subnet instance, right? Let's go to that public subnet instance. Here I'm entering. So what will happen? The request will come to the route table. From this instance, I'm trying to connect 10.10.2.170. Okay. Now what the route table will do? So these public route tables, I mean the public subnet route table is what? Public router. And what routes we have here? And if any IP 10.10, it's saying that search in local means local VPC. Apart from 10.10, go and ask the internet gateway. So now what is the IP address we are reaching? 10.10.217, right? 2.17. So it's starting with 10.10 obviously. So it comes under this. So where it need to look? The local VPC. So now what happens? It will search in local. It will search in the local VPC, right? Then the request will not go to the internet gateway now because it is searching in local only, because it's mapped the first rule. Then it is able to reach. So we'll access the administrator. Oh, sorry. Administrator. Get the password for the private server. Copy the IP and enter here and connect. Okay. This we already know that, we already seen that. We can connect to the private subnet instance from public subnet. Within the VPC, that communication will be there. But I have not drawn that thing here in the picture. Okay, don't confuse with this picture, this presentation. Okay, that part is not there. I mean, but by default, the route table will give us an access to over the local traffic. But in the picture, I mean, in the presentation, I have not made it. So if I want to make that, I mean, it will be very clumsy documentation and very clumsy picturization, so that you will not even understand. So that's why I didn't mention that. Okay, don't try to compare this picture with this connectivity. Okay, this is only for to give you the idea between the public subnet, private subnet things, not everything. Okay, it's like that. That's why don't try to compare with this one. Okay, now let's try to do that. Okay, got it. We connected to the private subnet instance. Now let's try to connect to the internet. Now I'll try to connect to the internet. Can I be able to connect? Yes or no? It will not. Why? I'm in private subnet. I'm trying to reach youtube.com. Why I will not connect? What is the reason? What is the reason? Exactly. I got the thing from Rupesh. for that exact thing. If you see our paper presentation, the PowerPoint presentation here. So what actually it happened is that, so what it will do, so from here I'm trying to connect to the internet. So the request will come to here, the route table. Okay. Now, what is the route table rules for the private router? It has only one rule, 10.10.search in local. But is that YouTube is there in 10.10? No. What is the IP address of youtube.com? We have sent 172.217. But we have only one rule here, 10.10. It is not obviously equal to 172.217. Then what it will say? I know only this rule. I don't know any other. So what will happen? The request, I mean, the things will be blocked here itself only. If we have an internet gateway rule, then it will map that 000 wildcard star, and then it will go to the internet gateway, and then from there it will reach the internet. But here it's not there, right? It is not there. So that's why we are not able to reach the internet from the private subnet instances. If you try to access also, you will not be able to do access it. It's the same thing. Let's see. Now understand what how basically it's like the traffic is going in between, I mean incoming and outgoing with VPC, the difference between public and private subnets, like which components make the difference, right? So these are, remember these steps always. First VPC, second subnets, then internet gateway, route table. So based on that you can create multiple subnets, you can create multiple routers. Gateway should be one only, one VPC, one gateway, but you can have multiple route tables, multiple subnets based on your requirement. But a route table might be either a public route table or a private route table. Means a route table can have internet gateway access, cannot have. Okay, so this is how we can basically create the diagram. How can we give the things? So this is what we have till now we did it. Okay, good, great, perfect. Till now, anybody have any questions here on this architecture, or like how these are all actually communicating, how we are getting access to public subnet, how we are not able to access the private subnet? Anybody have any questions here? That's what I'm trying to do now. That is the next thing, Abhishek. I mean, you cannot create internet gateway more than one internet gateway, Vijay, for a VPC. It will not be allowed. If you want to, you can give directly this only, right? You can make this connection only. If you want to give this subnet, you can give this only. But if you give this, what will happen? This also will become public subnet. As you will be having the two public subnets, simple. No, we can do that. That's what I'm saying. Rajesh will discuss. We will come into that point only. No worries. That is the next thing. We are not completed VPC yet. Okay. Now, good. So public subnet instances can access to the internet. Fine. Private subnet over the internet we cannot access, and from the instance also we cannot access to the internet. Good. But all the servers, they need internet access. Why? Because they need to download some updates and patches, or if the application want to send some information or send some emails, or if they want to communicate with some Windows, they will coordinate with Microsoft servers. For Linux, they will coordinate with Linux. For Oracle servers, they will like this. They'll be having some communication with their respective vendors and all those things. So obviously, you need private subnet instances. Also, you need internet access. But what is the idea behind private here? Is that so when you have like databases and application servers in private subnet, nobody else can reach. Hackers and crackers, they cannot be able to reach, because they will all come over the internet. They'll try to hack, and crack the websites and all those things over the internet, right? They'll try to do over the internet. Now, here what's actually happening? Now, if they want to come, there is no way they will not come. It's fine. That's great. But but here, by doing so, we are not even we are also not able to reach the internet. One second, guys. Sorry, guys. There's disturbance from my kid. Okay. So now here you can see by doing with the private, what happened is that we are also not able to reach the internet. I mean, we make some security by not anybody, not allowing them to reach our things. But even uh, that means like we are also restricting ourselves to reach the internet for sending emails, for downloading patches, installing patches, something like that, right? So how we can give, I mean, how can we counter this? We want this private to be private, means anybody from the internet, like a hacker, and I don't want them to access, right? So I don't want to allow outgoing, I mean incoming. So like incoming means from the internet, I don't want to allow incoming, but I want this instance to reach the internet, the outgoing. How we can do that, right? So we can do this by using the NAT, network address translation. We can do it using the network address translation. So let's take a break, guys, right? So that network address translation will only give the outbound to the instance but not incoming. Means from subnet you can reach the internet, but from the internet you cannot reach. That's how we are making the subnet. The private subnet is subnet, private subnet only, but on top of it we are giving the internet access. Okay, that is what basically the thing the NAT is basically of. So we'll take a break for 10 minutes. We'll take a break for 10 minutes, and once we come back we'll discuss that NAT. Okay, we'll how we can implement and how it works and all those things we'll see. Chalo guys, have a break for 10 minutes and we'll come back. Thank you. Hi guys, welcome back. Okay, now we kind of understand the requirement now, what we need to do, right? So we basically, our requirement is to um, give the internet access to the, so till now, till now it is like this. We are not able to, I mean, the private subnet instance is not able to reach the internet, right? So we need to give some way the access. How can we do that? Okay, so the answer is basically, as I told, we need to use the network address translation. In short, we call it as NAT. So we can use NAT, network address translation, to give only outbound connectivity, not inbound to private subnet resources. So it will not be inbound to private resources, but only outbound. So we will give some way. But if we make this one, this is not actually the solution. If we make this happen, if we create this path, if we attach here, what will happen? It give both internet and, I mean, incoming and outgoing, but this should not be. So we need to forget about this one. We need some other way, right? So the other way is we can do with two ways. Okay, both are NAT only, both are network address translation only. So we can use a network address translation gateway, NAT gateway, or a NAT instance. So you can give the private subnet resources internet access using either a NAT gateway or a NAT instance. Okay, so first we'll implement with NAT instance. Okay, then we'll understand how we can do it with NAT gateway. So there is no difference. Okay, basically it just a the only difference is that it's an instance, but wherein we'll be having a gateway. Okay, first we'll understand the concept, how we can do it and all those things, then we'll see the story. Okay, now we basically need to NAT server. So first let's try to understand what is actually the NAT. What will be the actually the NAT is all about. Then we can go with NAT instance and then we can implement it. First let's try to understand the NAT. So NAT means network address translation, as we seen. But what is actually NAT? Okay, I think hope you already kind of seen in some articles or somewhere in the videos or some, but let's try to focus it. So when first IPv4 got invented, like when we have only IPv4, okay, in the earlier days of IPv4, there is no concept called private IP, public IP, or there is no concept called NAT, right? So what happened is, in the early days of the IPv4 is that, let's say if you have some network of resources, means network means what? Combination of some servers, some devices communicating with each other, right? Okay, if you have some servers, some devices, and all need to reach the internet, if they all need to reach the internet, right? So what is the requirement at that at those days is that every system should have a public IP. Every system, I mean, if I have like six, I need six IPs, six public IPs. If I have, let's say, 100 systems, I need 100 public IPs. 100 public IPs I need. So this is what the requirement. So public IPs are actually not free, so we need to buy. Even one IP is like a kind of a very costly. So if you have like 100 systems or 200 systems, and if they want to buy those many IP addresses, it's like very huge investment, right? It's a very big investment, right? Now, what they did, and one more thing is that, so like we have different companies now and different people connecting to the internet. Okay, so why we need public IP is basically means we need to, if we need to connect to the internet, we need a public IP. That's the reason. So if you take any organization, there are like hundreds of thousands of members working on their systems, on their workstations, and they are always connected to the internet, right? They'll access Google, they will access their emails, they'll access their chat messengers and everything, like, right? They will take the request from the clients and all. They'll do the live chat, everything will be there. So basically you need to give the internet access. But if you take some companies like big companies, the top Fortune 100 companies, Fortune 50 companies like Google, Microsoft, right? So these have like thousands of employees across the globe, lakhs of employees across the globe. So if they want to provide internet to all of them, they need to buy those many thousands of lakhs of addresses for each employee. They need an IP address, right? So in that case, how many IP addresses we have in IPv4? 14 billion IP addresses, right? If it does that, if we do that, so we'll not be able to give that 14 billion IP addresses to the people who are connecting to the internet. Do we have only 14 billion? No, we have like crores of people there who are connecting to the internet daily, right? So in that case, what actually the same situation, I mean, the same thought came to the, I mean, came at those days itself to the networking people and the experts, the scientists, the people who does this R&D and D and the networking and all. So what they thought is like we need some kind of a way. We should not be like use each system needs an internet IP, I mean IP address for to connect to the internet. It's like it's kind of a waste of IPv4 kind of, right? So for that reason, like what they did, they come up with a solution called a NAT, right? And then when they're implementing the NAT, what they did is that they have this uh, given some IP addresses to as private IP addresses. After NAT only, they divided public and private IP addresses. Previously, it's all like normal IP addresses only. After NAT came into the existence, then they have divided this public and private IP addresses. Okay, they have given some A class private range, B class private range, C class private range, saying that okay, this is the IP addresses we can use in A class for private. So that private is free. You don't need to pay anybody to use that private IP addresses. It's all free. Now the requirement, how basically it is that, so all the systems which are in network, they'll use private IP addresses, not public. Okay, oh, that's fine. So the private IP addresses they can use, like if you have 1,000 system, you can use 1,000 IP addresses. If you have 1 lakh systems also, it's fine. You can have 1 lakh private IP addresses, right? Great. But if we want to connect to the internet, we need a public IP, right? So for that reason, what they'll do is, so we can use one public IP for all of these servers or systems. So which means thousands of multiple systems use one public IP to connect to the instances. Instead of each and every using a public IP, they can use multiple systems can use a single public IP to connect to the internet. So that is why you do one thing, simple thing after the session. If you are connecting to Wi-Fi, open Google and search what is my IP, right? You'll get the IP. Same thing if you have another laptop and another system, you do the same thing. You'll get the same IP address. Or maybe in your smartphone, if you have connected to the same Wi-Fi, not the data. I'm not talking about the data, right? I'm talking about if you connected to same to the if you connected to the same Wi-Fi and in your smartphone also try it. What is my IP? You'll get the same IP address. So basically, they're all, I mean, whoever are connected to your Wi-Fi, they're all accessing, I mean, they're all using one IP address to the connecting to the internet. The same like this I'm talking about. So here one device will be there. It will have a public IP, and these are all systems will connect to the this public IP to go and reach the internet. Okay, this topic we call it as basically the NAT, network address translation. No, it will not be there. The devices can handle that, Sandeep. It will not be disconnected. It will not be so slow and all. The devices can do that. They are capable of doing that. Basically, they're designed in such a way. Okay. Now, so what will happen? So let's say if this system want to access, let's say Google or YouTube. Okay. So the traffic in the network, what will happen is that in the internet and in normal traffic also, not in internet actually, in the network, in the networks, in the local network or internet everywhere, the communication will happen using a packets. So communication will be in the packets, right? So when you are trying to connect to some website, some application, you are trying to do something, what will happen is that that information will pass through the you I mean through the packets. In the packets it will travel over the cables and all those things. Okay. Now when you're trying to access Google or YouTube in somebody in this system, somebody accessing the internet, let's say they have implemented NAT. Now each packet will have source and destination field actually. So source means from where it is starting, the packet where it is coming from, and the destination is where it is actually going. Source where it is coming and destination where it is going. Now if you see this system having some IP address, let's say 192.168.0.1, let's say this IP address is. Now source is this one, 192.168.0.1. And what is the destination? The destination is what? Google.com, some IP address. Whatever it is, some XXX IP address. Now the packet will come here and will here, right? Now what will happen here is that what will happen, this device which has public IP configure, what it will do is in that packet we have source and destination, right? So it will change the source from this system IP address with the public IP. It will replace public IP and the destination will be same, and then it will forward the traffic to the internet. So it will reach the Google and come back here. Once it came back, what will happen? It will have the same two source and destination, right? Now it will have the public IP here, right? So once a packet came here, what will happen? The public IP will be replaced with again the private IP, whichever is requested, in our case this one, and then the packet will be the packets will be came here. So basically the traffic will traverse or follow through excuse me guys, okay, through this router or through this device. Okay. So basically the source and destination fields will change, especially the private IP and public IP will change. So when it come here, the private IP replaced with public IP. When it come here, it is trying to reach the instance, it will replace the public IP with private IP and reach here. It's like that. So basically what is happening here is that, right, you see that we call IP address as network address also, that we have discussed in the networking fundamentals video series. We can call IP address as a network address, right? Because it works in layer 3 network. Okay. So what is happening here, actually the IP address is changing. When you're trying to connect, the IP address is replacing, it's translating, right? So that's why this concept we call it as the network address is translating over while we are accessing the internet. So that's why the concept we call it as network address translation. So what is actually happen, like multiple thousands of devices will use one public IP address to connect to the internet. Simple. Okay, that is what the NAT is all about. Now what I'll do here, in the same I'll implement the NAT. Okay, how I'll do it is I'll create a NAT instance in the public subnet, which will I'll make it a elastic IP, sorry, public IP. I'll create a NAT instance I'll show you how we can create that, which can have, I'll create in public subnet. Okay, I'll do that. Come here, launch an instance, go to AWS community AMS here, search for NAT. Okay, there will be some instances, some Linux instances will be there which can be used as a NAT instances. You don't need to do anything. The operating system configuration is allowed that we don't need to do anything. Okay, let's click on NAT instance, just select that T2 micro we need, and we should be placed it in dev marshal VPC, that to be in public subnet. We need the public subnet, public IP. Let's go there, storage tags, we add it as a NAT server. Security group, I'll create a new security group. It's a NAT firewall, data marshal. So now you can see which is only allowing 22 port. Okay, I'll just go with it. Review and launch. Next, and click on launch. So anyway, I'm not going to log in, but I'll just select it, launch an instance. Okay, I have created this instance. Right? So now what purpose I have created? I have created to give the internet access for the private subnet, right? Now, my requirement here is that, so if any system is trying to access the internet, so I want all these private subnet instances should reach this NAT instance. It is not public subnet, I'm saying NAT instance. So they all need to reach the NAT instance. From here, they will use this path, the public subnet instance path, to reach the internet. But how can we make the all private subnet instances to reach the NAT instance? Right? So here what we'll do, we'll take the help from the route table, the router. So what we need to do is we need to make a path to the NAT instance, NAT the subnet. Remember that we are making it to the a path to the NAT instance. How we do it is basically we'll see now. To do that, to make the communication from the private subnet, right? So we need to take private subnet, edit routes. We need to add a route. So we'll say like all IP addresses should go to where instance. Select as an instance. Okay. Select as an instance. If you're on NAT gateway, you can select NAT gateway, but we'll see. I mean, if you're using NAT gateway, you can select that. Okay, click on instance. And here we have like a couple of instances there, NAT server and all those things. Let's click on NAT server. Okay, NAT server instance, click on save change. Route successfully edited, click on close. Okay, now we did that, right? So once we did, now what I did means as a route I added, so I make this change, right? This change I made it. These were the change I made it, right? Now, so we have the full path like, so from here it will come here, it'll go here. From what NAT instance will do, it will take that request, the packets, and follow it through its path. I mean, this is NAT instance path, right? Because it's in public subnet, so it will do it. I mean, which one you're talking about? It's like this route table you're talking about. I mean, Ashok, is that the same thing? Simple. You come here, add edit routes, add all IP addresses by adding 000. Then here we need to specify. Simple. We need to select an instance. Select instance, and we have like 3 instances. Select the NAT server and save. That's it. Same like internet gateway only. What we did, we have associated internet gateway, right? Now we associated with instance, that's it. Okay, now these two work. Okay, we did that, we did the make change, right? Now what we need to do is we need to do one more change. Go to your instance, NAT instance, go to actions. In the networking, there is an option called change source destination check. Change source destination check. I'll just click on it. By default, it will be enabled. By default, it will be enabled. What we need to do, we need to disable it. I disable the source and destination check. Okay, I will tell you why I did that and what is that. Okay, give me some time. I'll explain you later. Okay, I did that change. Now you see this path now. So now if I go and access internet in subnet 2, now we have all the paths set up. Seems to be, can we able to access the internet? I mean, now we have all the things set up, right? Can you think? Okay, let's see. Can we able to do it or not? Previously we are not able to reach YouTube. Let's refresh. We're trying to reach YouTube. We are not able to reach. What is the issue now? Anybody guess what is happening? What is missing here? Okay, Ashok, I mean, what do you want me to do? I enabled that only. Okay, it's fine. So I mean, do I need to do something else for give the internet access or what? So now we see, guys, I mean, we have all the paths set, but somehow something is not working here. I enable the source and destination. Now it's working fine. We need to enable this. Sorry, we need to disable that source and destination check. If we enable it, it will not work. We have to disable only that source and destination. But there is something is missing here. Does anybody can guess what is actually? You're right, Ashok. Actually, true. I got the answer from Ashok. Where do you think I need to give the internet gateway? If I give the internet gateway access means it will be public subnet, right, Vignesh? You're saying this one, right? Is that what you're saying? Then it will be public subnet, right? Will not be private. Just think about that picture. I mean, see like how the network is flowing. I mean, how the traffic is flowing. There is something missing. You can see that something is actually, what I can say. Because of something, it's not working, man. That is for sure. Yes, Vignesh, but where it is that? So basically, the thing is that, so while creating the NAT instance, I have created the NAT firewall, right? The NAT firewall only allows 22 port only actually. By default, remaining all will be, what will happen? It will be denied, right? Now we are accessing YouTube and all. It will access on port 80, port 403, something like that, right? So prior to reach the NAT instance, we have the security group which only allows 22. Remaining all will be blocked. right? So that's why it's blocking here only. It's not reachable to the NAT gateway, sorry, NAT instance. Okay. Now what we need to do is basically we need to NAT server firewall. So if we are accessing on browser, so 80443 is required. If you want to access Google or YouTube, like we need 8R443. But what if your instance, I mean, if your server need to access Microsoft to get the updates, download, and all those things, right? So we need, I mean, we are not quite sure about like what ports need to be there and all. So if you are sure, we can add only those ports. But for now, what I'll do, I'll just go to the inbound. I'll say edit. What I'll do is I'll add a rule to allow all traffic from only the private subnet. What is the private subnet? I think 2, right? I think it's 2, seems to be, right? 2.0 means whatever the IP address 10.10.2 will means private IP, right? So I'm allowing all the private subnet instances, all traffic. So whatever the traffic is coming from the 10.10.2. Any other IP address, any IP starting with 10.10.2 will be accessed, allowed in the NAT thing. Okay. Now let's go and see. Now do you think it will work? Sure? Paka? Do you want me to lock? Do you want me to lock the answer? Okay, let's see. We'll go to the computer and ask the answer by refreshing. So it's working, right? Okay. Understand how it is working and how it is flowing now, the thing. So I just only need to give you the answer for the what? The source and destination check, why I disabled it. Right? Okay, now I will tell you what is that source and destination check so that you can understand what is this all about. Okay, chalo. Let's go and discuss that. Let's take an example, simple example. You received a letter or some postman came to your home and he gave you letter. Forget about what is that letter. He delivered some letter to you and you see that letter and you're not actually expecting any letter from anybody. You know that. You're not expecting anything. But I mean, postman some accidentally or wantedly or so he delivered to you. Forget about why he did that and all those things. He gave it to you. Now you are not expecting any letter from them. So what you say? You see the to address. Is it really to me or somebody else or something like that? So you see the to address. Like on the every letter you'll be having from and to addresses, right? You see the to address and you see that it's a different address. It's not your name, your address, and it's not your details. It's not your address. And sometimes maybe if we send some letters, it will also return back to us. So maybe you thought that maybe somebody wrote a letter from my home. Maybe it is written got to return. So then you kind of see the from address, who sent it, and who the from address is also not you and your address. I mean, it's not the person or the name you've never seen that address, and from is you don't know. Two is you don't know. What you'll do? You basically either give it back to the postman if he's there. If it is not there, you just tear it up and throw it in the dustbin. You throw it in the dustbin. If you're curious, like you maybe tear it and open and see what is there in that, right? uh, Most probably we'll just see and then throw it in the dustbin. We'll reject it simply, right or wrong? So just You understood, right? What I said. Now make a note of it, and then we'll come here. We'll come here to our same the thing what we are discussing, the NAT. Look at this path. Now I told that it is asking YouTube, right? It accessing youtube.com. The packet will come from here. So what is the source? This IP address 10.10.2.170. youtube.com address is 172.217 something. Okay, packet will travel here. From here it will reach. Okay, packet came here. Now every operating system or every device, this by default source and destination check will be enabled. Means when it receives some traffic or packets, what they will do is they will check the source and destination information. Every device, not just laptop or server, every device when it received some traffic, it will check. I mean, traffic means what? In the packets, right? So in that packets, every device will check the source and destination. Now this packet came here. In that packet, who is the source and who is the destination? Source is NAT instance 10.10.2.170. What is the destination? YouTube. Means 172.217 something IP addresses. NAT instance, what it will do? It will check the source and it will check the destination. Same thing, like you can compare with the letter which you received. So source is not NAT instance, right? 10.10.2.170, it's not instant, not NAT instance. And what is destination? YouTube 172.217. Obviously this NAT server is not the YouTube server. So what NAT instance will do, NAT server will do, I am not the source, I am not the destination. So what it will do, it will basically reject this traffic, right? Then what will happen? The traffic will end up here only. Again we'll have the same situation. The private subnet instances will not get to the internet, right? So if this NAT instance should not check who is the source and who is the destination, what we need to do? We go and in the actions, in the networking actions, what we did? Disable source and destination. Don't check any packet which is coming to you. Don't check for source and destination. Whenever packet come, just ask through, go away from your, so it will follow through. That's it. It will pass through. The traffic will pass through. So that is why we basically disable the IP, sorry, source and destination check. Okay, now if I go and I'm in this private IP, private subnet instance, and if you go and check what is my IP in the private subnet instance, it is saying 13.222.155.128, right? This is the IP it is giving. So if you see what is this IP is, right, 13.229. If you go and see the IP address, what is the IP address? You see 13.229.50. So basically this, it is using the private subnet instances are using the public IP of NAT instance to reach the internet. That's what we set up, right? It's using it. So we did it correctly only. Right or wrong? Right. So this is what basically the thing is all about. Okay. Understand? Any questions? So in the place of NAT instance, what you need to do, you can use NAT gateway also. You can create an NAT gateway. How we can create a NAT gateway? Simple. Go to the VPC. Here you can see NAT gateways will be there. You create an NAT gateway. You don't need to do this source and destination check. You don't need to disable it. By default, the NAT gateway will be there. So create a NAT gateway, and then in the route table, you just need to, instead of the NAT instance, here instead of the NAT instance, what we need to do, you select the NAT gateway. That's it. Done. The thing is done. But this NAT gateway is not basically uh, a free one, so you'll be charged. So that's why we didn't cover. But in the organizations, people use NAT gateway only, not NAT instance, because when we use NAT instance, what will happen? We can save some cost. We can save some cost, but the thing is that that is a single point of failure, which means if there is an issue happen to the NAT server, if the server is down, if there is an issue with the availability zone where that instance is there, something happened, what will happen? Your private subnet instances will not get to the internet. So it's a single point of failure. But wherein if you use NAT gateway, it's not single point of failure. It's kind of a load balancer. It will have multiple instances behind the scenes. AWS will maintain that. We don't need to worry about the availability. So we can 24 by 7 will get the internet. So I mean, if you pay more, we will get more. It's like that. But the fact and how it works and the concept and everything is same, right? So no, yes, you're true. Without public subnet, you can't do that. Rajesh, true. You need public subnet for sure. Okay. Now the same. Now we can access the internet. Now we can have here I created only one private subnet, one public subnet, but you can create multiple public subnets. Like here I created one, it was there, and here one more I can create. So if it is a public subnet, what I will do, I will just simply associate the public subnet with the public route table. If I create one more subnet as a private, what I'll do, I'll just integrate with the route table. That's it. So if I associate with private route table or public route table, whatever it is, right? So if I associate with the public route table, it will be a public subnet instance. If I associate with the private route table, it will be a private subnet instance. So you can have only, I mean, you can create multiple route tables, but two will be more than enough. One will be public and one will be private, and n number of you can create, I mean, not a number means you can create up to 256, right, in the subnets. So those subnets either you can attach it to here or here. So like this you can go and create multiples, right? So these are basically you can create the network step by step, the VPC. So this will be the important interview question. They'll simply say that tell me the procedure to create the VPC in the internet in the interview. They'll simply say that. So you practice this, you practice this 2-3 times so that you can understand the process. Only few steps, but you need to understand the flow, how we do, what we need to do, and all those things. Okay, that is very important. How can two instances in different VPC communicate? If you want, I mean, over the internet, if they want, you can communicate. Other we need to do it the VPC peering or transit gateway. If both are in internet, I mean, if both are in public, like over the internet, you can do it. First thing is that over the internet we can communicate. So VPC is like what, network, right? We can go with transit gateway or VPC peering. I mean, VPC peering is like a old thing. They are replacing it with transit gateway. So a gateway will be created between the VPCs. So using that way gateway, the VPC will communicate. A device will be placed between the, and you want me to show, that's what you're asking? No, that's not in our curriculum. If you want, like, you go just simple, you go and Google it, you'll get it. It's simple. I mean, we already got the actual things and all. You just need to create this transit gateway and you need to associate. That's it. Nothing much configuration. Simple. You see, connectivity across VPCs. Simple. You can't do that, Rupesh. You cannot add it. I mean, it's like you have to go there and place your desktop or system. It will not be possible. Over the internet we can connect, but we cannot place. Okay, so this is what basically it is. How many more sessions are there to complete? Three, Khalid. Tomorrow one, and then we have in the next weekend two more. So total three we are going to complete. And there are only I think two services, important services left. Remaining all I mean, it's kind of a small services, not much important. Okay, so I'll start just the basic of the service, one service. I'll just give some introduction, not more than that, which is called an S3 actually. I'll just give some, I'll take just 10 minutes, not more than that. After 1 month, Khalid, after exactly 1 month. Okay, so I'll just give an just introduction to one service, and then we can go and complete the session for today. We'll meet tomorrow. Okay, so I'll just give yeah, sure, don't worry. I will do that, no worries. I didn't get the question, Khalid. You're asking, Khalida, sorry. Can we communicate two different region instance with each other using route? I mean, you're saying route table. You can use that AWS Transit Gateway, what I told, if you want. But I mean, again, that directly you cannot create a route. I mean, because VPC is a region specific. When I create a VPC, it will be there in a single region. It will not be in multiple regions, right? So it's like that. Okay, so the next service we are going to cover is called S3. S3 means 3S actually. Okay, simple storage service. Okay, simple storage service. So what is this simple storage service? It's another storage service, nothing else, but it's a different storage service. Means we have seen the storage service EBS, Elastic Black Store, right? It's basically a block level storage, means which can be associated with the instances. We can use it as a hard drives. But this is, it's a file and object storage. Means it's like a Google Drive or Dropbox. So like we use Google Drive, right? So it's not associated with our instance or servers or laptops. It will be there on the internet. It will be there. You can upload your files and data and videos, like any form of data you can upload. And whenever you want, you can view there, you can download. It's like that. So same like Dropbox also, you can upload files and it will be there. If you want, you can download it, right? So it's like a file storage, same like Google Drive and Dropbox. And it's an unlimited storage service, which means there is no limit of storing your data. So you might have whatever the data you might have. You might have 10 petabytes or 100 hexabytes, whatever the data, how much big or massive data you have, you can upload it to S3. It's an unlimited storage service. There is no limitations for S3. But again, if you are using that much, means we have to pay. That is for sure. Okay, remember this. So but it's an unlimited storage. Like if you see, compare with EBS, the max we can create a volume is what, 16 terabytes. There's a limitation there, but here it's not like that. You can have n number of data, you can upload it, n number of size of data, you can upload it to S3. I mean, you can store it in S3. So it's a storage service you can use to store your data, and the data of any size, small, medium, or large, or heavy, whatever the data is there, you can go and upload there, you can store there. So we don't need to worry about the storage requirements. Okay, and then it's highly available. means whenever you want to get, you have uploaded your data, whenever you want to get your data back, you want to view your data, so it will be available. And the availability is, it's like 99.99% availability. So what is meant by 99.99 means, let's uptime dot is, I think I'll just open a website. So what is 99.9 means? So if it is, this is the SLA actually, high available, which means, so at some point of time, if in a day, or in a day, if that storage is not available, what is, how much, I mean how much time it may not be available is, in a day, 8 seconds, 8.5 seconds, it might not be available. It might not be, not, it's must be, it must not be. That is what 99.99 means. In a weekly, it's 1 minute. In a monthly, 4 minutes. I mean, if you take a whole month, maybe you might not be able to access for around 4 minutes. Not continuous, I mean, not continuous 4 minutes. So in a year, it's like around 52 minutes, not even an hour. So this much highly available this storage is. Okay, this much highly available this storage is. At any point of time, you can go and access your data. You don't need to worry about, like, let's say I have uploaded the data and storing in S3. I woke up at midnight, 2 a.m. Can I be able to access my data? Or maybe in the evening 5 p.m. I'm trying to get my data back. Can I be able to access? Yes. Right. So, but how they will actually make this data possible? 99.99% is that what they will do is, they will actually store the data, whatever the data we upload, right? So they'll store the data across availability zones. This S3 is basically, it's a region specific. Means when we create an instance, we are creating in an availability zone. But this S3 is not availability zone centric or availability zone specific. When we upload the data, we'll upload it to region like Singapore, Mumbai, London. Then what S3 will do is that S3 will store it in across availability zones, so that we can get 99.99% availability. How they will store it is, let's take this example as how actually makes data highly available. Take an example, this is the region, one region, any region. Okay, now in that region we have three availability zone, 1A, 1B, 1C. Let's take maybe a Singapore, like we have three regions. Okay, now we have three availability zones in a region. But as we discussed in, while discussing EBS, we discussed that availability zone is not actually a single data center, right? So availability zone is basically a combination of multiple physical data centers, right? So that availability zone is basically what? A multiple physical data centers. Means in an availability zone, there might be a 2 or 3 or 4 or 5, like there are 4 or 5, or maybe we don't know what is the count, but we'll be having multiple data centers, multiple physical data centers combined as an availability zone. Now this has four, let's say take an, I'm just assuming that, okay, this is four data centers in an availability zone. Here we have three data centers in availability zone. Here again we have like four data centers in availability zone. Now this is a structure, okay, that we already know. Now here I'm a user is there, I'm uploading a file, I have a file, let's say some file is there and I want to upload, and that file I want to, I don't know, like when I maybe want to get the data, get that file, it need to be available all the time. Whenever I want to get the data, it should be there. I just go there and get my data, right? So the file is there, and if I upload it to region, as I told, that we upload it to region, right? So when we upload it to region, what actually AWS S3 will do is it will upload to the all the availability zones. They'll upload it to the all the availability zones. And availability zone means what? It's like it's not a single data center, right? It's multiple physical data centers. Then what AWS will do? That files will be uploaded to all the data centers in all the availability zone. So that's why even if one availability zone is down, or if one data center down, you can go and get your data. So at any point of time, if you want to view your data or get your data, download data, you can get it from anywhere. You can get it from here or here, maybe here or here or here. These are all available. If something is down, one or two will be down, or one or two availability zone, but still you have a lot of there, right? So that is how you can get. Let's take an example. There is at some point of time when you're trying to get your data, this is down and this is down, and let's say this is down. These three data centers are down, but still how many are left? You see, you can get your data. Or let's say if this whole availability zone is down, this one, still you have two more availability zone which has data centers, you can get it, right? So this is what basically how actually AWS makes this highly available, that AWS S3 makes our data highly available because they will store it in different locations across the availability zones in a region. That's where they maintain this much availability. These are spread across availability zones. And then there's one more important thing is they are 99.9999999 some 9% durability. It basically, if you count, it's 11 nines durability. It's 11 nines durability. So what is durability means? Let's take this example. What is how is durability means? Let's take one data center. I'm talking about only one data center, okay? Not multiple data in an availability zone or a region. I'm talking about only one data center. Let's take one. This is one data center, and you have a file is there. And in the data centers, what will happen? You'll be having this kind of servers will be there. The storage servers. This one server, okay? This one server is there, and each storage server will have multiple hard drives. You see that? Here there are like multiple hard. You see that around 8 hard drives are there here. 1 2 3 4 5 6 7 8 8 hard drives are there here. Okay, this is only one server, but in the data center you might be having multiple this storage servers. Multiple storage servers will be there, and when you upload your data, you upload it to multiple storage servers, and which means your data is like what? If you upload it to a single server, which means it will be uploaded in more or less almost your data will be there in almost in those 8 drives. I mean, it's not like exactly all your data is in 8 drives, but it's some portion. They'll use kind of RAID technology. I'm not sure like how many of you know, but I mean this they use this. But basically, to get you an idea, they will use this to like basically store in multiple hard drives. So which means not even we are talking about a single server in multiple hard drives, and you'll be having multiple servers in a data center, and you'll be having multiple data centers in a availability zone, and you'll be having multiple data centers in a region. I mean multiple availability zones in a same region. And if you see the same thing here, you see we have just took around only one data center, but the same thing will be there in multiple data centers, multiple availability zone. So that's where, so what is this durability means? Basically durability means your data will not lose, right? I mean you upload data to S3, and you want, I mean there are some videos there, your personal videos are there, and you want those videos to be available lifelong. Is AWS can Make sure that it will be available after 20 years, after 50 years, after 100 years also. Will it be available? Yes, it's available. What is SLA? How much you can say that? 99.9999% I can say that yes, you will be there. Means in a 1 million files, if you upload 1 million files, there may be a chance of losing a one file. That is what this 99.99911 durability means. Availability is different. Availability means, can I connect to S3 to get the data back or not? I mean, is S3 is available or not? The service is available or not? Like internet, can I able to reach the internet or not? This durability means, is the data is there on the S3 or not? Right? So it's like that. So 11 nines of durability, right? 4 nines of availability and 11 nines of durability. So these are basically, they'll make this S3 is highly available and highly durable. And we can store the data from as minimum as 1 byte to 5 terabyte. Here I told it's an unlimited storage, but here I'm telling you some sizes. What is this? Right? So this I'm talking about a single object here. You can upload to S3 a single object size from 1 byte to 5 terabyte, which means I've never seen a file which is 5 TB. I've never seen a file even 1 TB also, but I'm saying that. Okay. So a single file size, if you have a file which is more than 5 TB, let's say, that file you cannot upload it to S3. That is a requirement. Okay. But if you have a file which is some 10 TB, 20 TB is there, do we have any option in AWS? Yes, we have an option in AWS, but we'll see later. Okay, but for now in S3, the maximum file, single files I'm talking about a single file size. So you can upload 5 terabyte files of 1000 or 1 lakh. It's n number of files you can upload of 5 terabyte, but a single file size not more than 5 terabyte. So these are basically the essentials of S3. Okay. Now we have discussed about what is S3 and how they store and what is just the essentials we discussed, right? So now to store the data in S3, what we'll do is we'll create a concept called bucket. Bucket means basically it's like a container where we store our data, or you can say it's like a folder. You can say it's like a folder. You create a folder and then we place the data. That's what basically the bucket. And so to upload data to S3, we need a bucket. Without bucket, we cannot store the data. So first we go and create a bucket, and then in that bucket, we place the data. So we create a bucket and then we upload the data. So in number of data, we can upload folders and everything we can do it, right? And while creating the bucket, so as I told that if you want to upload the data to S3, we need a bucket, right? So while creating the bucket, we have to mention the region. In which region you want to create that bucket, which basically in turn store our data. So as I told, S3 is in region specific, means when we are creating a bucket, the bucket will be created in a region, not in an availability zone, not in a data center, right? You can select Singapore, Mumbai, whatever it is. Then you can go and do it. So these are basically the basics of S3, and I don't want to go more now, right? So basically we just understand what is S3 and all, what is S3 bucket and all. So in the next session tomorrow, we'll start doing some practicals, like how can we create the buckets, how can we upload, and what are the options we have in S3, and all those things we'll see. Okay, this is it for today's session, guys. So if you have any questions, you can go ahead. You're talking about Collabora exam, right, Manjusha? That will be after 1 month, completion of after 1 month. I mean, whenever our course completed, right? So after 30 days, they will conduct. Yes, the same Sandeep. Yes, certification exam only. True. Which credentials you're talking, Sandeep? Route 53, you're saying? You will get, you send an email, one more follow-up email, maybe call them. Uh, how many more sessions left? We have only 3 more, then we can complete. You can use it maybe for like 3 months after the session completed. You can use it for 3 months to practice. We'll do that, Kalidas, in the last session. I'll show you the process, Neha, so that you can understand. The daily routine tasks, Vignesh. I mean, whatever we are doing actually, right? So it's like you might get requirements for creating the instances, creating the databases, or maybe scaling up, scaling down, or they might ask you about some troubleshooting. Like they'll say that, I mean, this application is not working, that application is not working. They might say, I mean, from there is one user in US or some Australia, they are not able to access. So like this kind of things will be there. No, it will not be practical. I mean, we can't do the practical because it will take a lot of time. I mean, even I don't have a server to show you. That is the reason. There's one more thing is that that we'll discuss tomorrow. Mostly we'll have, but maybe in a different time. We'll see. I mean, we'll discuss tomorrow. We'll have the sessions for sure next weekend, but it might be, let's see. I mean, because it's kind of, I mean, the maintenance is scheduled for me. I mean, somewhat people are not saying, and people are not prefer to change. We'll see. I mean, somebody like somewhere we need to kind of take some time and do it. Yeah, basically it's an objective type questions only. Yes, true. True, Santosh. We'll see in the last session, Santosh, so that you can understand how the questions will be and how you can answer and all those things. The questions and all we will see in the last session so that you can better understand. Do some practice, guys. Okay, so that you can have a better idea. Any questions, guys? Any more questions? Okay, guys. So let's go and finish the session for today. We'll meet you tomorrow at the same time. When I was doing the auto scaling, I got the message. You refresh it one more time, Sandeep. I told you, right? So it didn't work out. You retried also. That's what I'm saying. For the first time, it might give you some error. Sometimes it will, yes. Go ahead, Sandeep. Now you have created RDS. Okay, it's great. Next, you create it for second time. Okay. I mean, you have not seen, or what is that? Port double three. I mean, you're saying for obviously it will be there actually for every database. It will be there. It should be there. You do it one more time. Maybe you can see that it will be there for sure. Uh, I mean, you need to open the port in security group, Sandeep. Have you opened it in security group, which is associated with the RDS instance? It should work actually in that case. I mean, have you given that 3300 only in the application while installing? Or you're going with 3306? Is it, have you created the, while creating the RDS, which one you selected? You selected public or private? Public accessibility, yes or no? Then it should access. It should give you the access. If everything is perfect, I mean, you will not get any issues, Sandeep, for sure. If there is something, then there might be some issue. Check it out one more time, the configuration and all. Then you see, or maybe you create a from scratch one more time. You changed it from 3300 to 3306. It worked. In that case, I mean, while installing the application, you have not given the 3300. Might be. Okay, guys. We'll meet you tomorrow at the same time, 8 a.m. ST. Chalo, guys. Make sure you give the feedback. Once you close the session, you will get a feedback link. Give like whatever you feel, right? Thank you, guys. See you tomorrow. Bye.